In this lecture we will find the radius of a circle. As you can see in the drawing, we have a circle, and the center of this circle is at point O. Chord AD equals to 10 units and chord BC equals to 5 units, and this angle is a right angle, that is to say it equals to 90 degrees, and we want to find out the radius of this circle. First of all, I will explain you what is a peripheral angle. Okay, so the definition of a peripheral angle So actually a peripheral angle is an angle inside the circle its vertex is on the circle, and its curves are chords in the circle. So I will read the definition of a peripheral angle again. A peripheral angle is an angle inside the circle. Its vertex is on the circle and its curves are chords in the circle. Okay, so now I will show you an example of a peripheral angle in order to clarify the definition of a peripheral angle. So I will draw a peripheral angle. So a peripheral angle is inside the circle, so I will draw a peripheral angle inside the circle. So actually angle alpha is a peripheral angle because it is angle inside the circle. The vertex of angle alpha is at point A, and point A is a point on the circle, and the curves of angle alpha are chords in the circle. Curve AB of angle alpha is chord in the circle, and curve AC of angle alpha is also chord in this circle. And also the peripheral angle alpha rests on chord BC. Okay, peripheral angle alpha rests on chord BC. Okay, so this is an example of a peripheral angle. You can see that a peripheral angle is an angle that is inside the circle, and its vertex is on the circle. The vertex of angle alpha is at point A, and point A is on the circle, and the curve AC of angle alpha is chord in the circle, and curve AB of angle alpha is also chord in the circle. And peripheral angle alpha rests on chord BC. Okay, so that is the definition of a peripheral angle. A peripheral angle is an angle inside the circle. Angle alpha is inside the circle. Its vertex, that is to say, the vertex is on the circle. Point A, that is the vertex of angle alpha, is on the circle, and its curves are strings in the circle. Curve AC is a string in the circle, and curve AB of angle alpha is also string in this circle. Okay, so that is the definition of a peripheral angle. Okay, so we will return to our drawing. And we will draw a chord through points A and O. Again, we will draw a chord or string, it is the same. We will draw a chord through points A and O. You should remember that point O is the center of this circle. Okay, so we will draw a string through points A and O. Okay, and we will call to the touching point between the string and the circle point M. Again, point M is the point of contact between the circle and chord AM. Okay, we actually can say that chord AM is the diameter of this circle. So I will write it down. chord AM, the red line is the diameter of the circle. Because of the fact that chord AM passes through the center of the circle, because of the fact that chord AM passes through the center of the circle, and the center of the circle is point O. That is to say, point O. So I will read again the things that I wrote. Chord AM is the diameter of the circle because of the fact that chord AM passes through the center of the circle, that is to say, point O. Okay? Any chord that passes through the center of a circle is defined as the diameter of that circle. And because of the fact that chord AM passes through the center of this circle, that is to say through point O, that is the center of this circle, for that reason chord AM is the diameter of this circle, that is to say it also equals to 2 times the radius of this circle. Okay, again, chord AM is the diameter of the circle because of the fact that chord AM passes through the center of the circle, that is to say from point O. Okay? In the next step, we will connect together points M and D by a straight line. And we actually have a rule. I will call it rule number 1. Rule number 1 states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. So I will read again rule number 1. Rule number 1 states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. Now I will give you an example of a peripheral angle that rests on the diameter of a circle. So suppose that chord AB is the diameter of this circle, then any peripheral angle that rests on this diameter will be equal to 90 degrees according to rule number 1. So actually, if we have a peripheral angle so peripheral angle ADB, angle ADB rests on chord AB. So you can see peripheral angle ADB rests on chord AB, and chord AB is the diameter of the circle. We defined chord AB as the diameter of the circle. For that reason, according to rule number 1, peripheral angle ADB will be equal to 90 degrees. Okay, so peripheral angle ADB will be equal to 90 degrees because of the fact that peripheral angle ADB rests on the diameter of this circle. Okay, peripheral angle ADB equals to 90 degrees because of the fact that it rests on the diameter of this circle. That is to say, it rests on AB, chord AB, that is the diameter of this circle. So according to rule number 1, we can deduce from it that peripheral angle ADB equals to 90 degrees. Okay? So that is the explanation of rule number 1. We have peripheral angle ADB that rests on chord AB, and chord AB is the diameter of this circle. For that reason, according to rule number 1, peripheral angle ADB equals to 90 degrees, and actually any other angle that rests, any other peripheral angle that rests on the diameter of this circle, that is to say on chord AB, will be equal to 90 degrees according to rule number 1. Okay. So actually we can implement this rule in our circle because we have angle ADB that rests on AM, and AM is the diameter of this circle. Okay, I will write it down. Angle ADB rests on chord AM and chord AM is the diameter of this circle. Therefore, according to rule number 1, peripheral angle ADB equals to 90 degrees. Okay, so I will read what I wrote again. Peripheral angle ADB rests on chord AM. So you can see here, peripheral angle ADB rests on chord AM, and chord AM is the diameter of this circle. For that reason, according to rule number 1, peripheral angle ADB equals to 90 degrees. Okay, so we can write here that peripheral angle ADB equals to 90 degrees. I will write it here. Peripheral angle ADB equals to 90 degrees. Peripheral angle ADB equals to 90 degrees. So it is a right angle. Okay, according to rule number 1. Now we will focus on the right triangle AMD. AMD is a right triangle because of the fact that angle ADB equals to 90 degrees. So we will focus on the right triangle AMD. We will define angle AMD as angle alpha. So angle AMD equals to alpha. And angle AMAD will be equal to beta. Okay, angle MAD will be equal to beta. So in the right triangle AMD, angle AMD will be equal to alpha, angle AMD will be equal to alpha, and angle MAD equals to beta. Angle MAD equals to beta. As you already know, the sum of the angles in any triangle in the world equals to 180 degrees. So, especially in the right triangle AMD, the sum of its angles equals to 180 degrees. So we'll create equation number 1 that states that the sum of the angles in the right triangle AMD equals to 180 degrees. So what is the sum of the angles in the right triangle AMD? It is actually alpha plus beta plus 90 degrees. So I will write it down. Alpha plus beta plus 90 degrees equals to 180 degrees. It is true for any triangle in the world. The sum of the angles of any triangle equals to 180 degrees. So we created equation number 1 that states that the sum of the angles in the right triangle AMD equals to 180 degrees. The sum of the angles in the right triangle AMD is alpha plus beta plus 90 degrees, and it equals alpha plus beta plus 90 degrees, it equals to 180 degrees. Okay, so we will subtract 90 degrees from equation number 1. We subtracted 90 degrees from equation number 1, so alpha plus beta plus 90 degrees minus 90 degrees equals to alpha plus beta, and 180 degrees minus 90 degrees equals to 90 degrees. In the next step, we will subtract alpha from equation number 1. We will get that beta equals to 90 degrees minus alpha. So we subtracted alpha from equation number 1. Alpha plus beta minus alpha equals to beta, and 90 degrees minus alpha equals to 90 degrees minus alpha. So we have equation number 1 that states that angle alpha equals to 90 degrees, angle beta equals to 90 degrees minus alpha. Okay? In the next step, we will connect together points A and B by a straight line. And we will define the vertex of this right angle as L. The vertex of this right triangle is defined as L. So actually in the right triangle ABL, we first of all we will talk about rule number 2. We will arrive to this right triangle ABL after I will explain rule number 2. So rule number 2 states that if two peripheral angles rest on the same chord, then they are equal to each other. Okay? If two peripheral angles rest on the same chord, then they are equal to each other. I will read rule number 2 again. Rule number 2 states that if two peripheral angles rest on the same chord, then they are equal to each other. So I will give you an example of two peripheral angles that rest on the same chord in order to clarify rule number 2. So actually, if we have peripheral angle alpha, as you can see from the drawing, peripheral angle alpha rests on chord BC. Okay? And we have another peripheral angle beta that rests on the same chord BC, you can see from the drawing that peripheral angle beta rests exactly on the same chord BC. So according to rule number 2, they are equal to each other. That is to say, angle alpha equals to angle beta. Okay? So according to rule number 2, alpha equals to beta because of the fact that both angles, alpha and beta, rests on the same chord BC. Okay? Because both alpha and beta rests on the same chord BC. For that reason, according to rule number 2, angle alpha equals to angle beta. Okay, so that is the example of rule number 2. Now we can implement rule number 2 in our circle. Angle AEMD that equals to alpha rests on chord AD. I will write it down. Angle AMD equals to angle alpha. Angle AMD equals to alpha. Rests on chord AD. And angle ABD also rests on chord AD. Okay, I will Read again. Angle AMD that equals to alpha rests on chord AD. Angle AMD that equals to alpha rests on chord AD. And angle ABD also rests on chord AD. Angle ABD also rests on chord AD. So according to rule number 2, angle ABD will be equal to angle alpha because both those angles rest on the same chord AD. Therefore, they are equal to each other. That is to say, angle ABD equals to angle alpha. Okay, so I write it down. So according to rule number 2, those two angles that rest on the same chord, those two angles that rest on the same chord are equal to each other. So I will read what I wrote. So according to rule number 2, those two angles that rest on the same chord are equal to each other. So I read it again. So according to rule number 2, those two angles that rest on the same chord are equal to each other. That is to say, angle ABD that rests on the same chord as angle alpha equals to angle alpha. Okay? That is to say, angle ABD that rests on the same chord as angle alpha equals to angle alpha according to rule number 2. Okay? So, actually, we know that angle ABD equals to alpha. Okay? Angle ABD equals to alpha. Now, we will focus on the right triangle ABL, and we will define angle BAL as x. So, in the right triangle ABL, we defined angle ABL as x. Angle angle BAL, actually it is angle BAL equals to x. Okay, angle BAL equals to x is defined as x. Again, in the right triangle ABL, angle BAL equals to x. Okay? In the right triangle ABL, angle BAL equals to x. And we also know that the sum of the angles in any triangle in the world equals to 180 degrees. And especially it is true about the right triangle ABL. The sum of its angles equals to 180 degrees. So we can write down that alpha plus x plus 90 degrees equals to 180 degrees. Okay? That will be our second equation. Alpha plus x plus 90 degrees equals to 180 degrees. So our second equation states that the sum of the angles in the right triangle ABL, that is to say alpha plus x plus 90 degrees, equals to 180 degrees. Now we'll subtract 90 degrees from equation number 2. So we subtracted 90 degrees from equation number 2. We got that alpha plus x plus 90 degrees minus 90 degrees equals to alpha plus x, and 180 degrees minus 90 degrees equals to 90 degrees. In the next step, we'll subtract alpha from equation number 2. So we subtracted alpha from equation number 2. Alpha plus x minus x equals alpha plus x minus alpha. We subtracted alpha from equation number 2. So alpha plus x minus alpha equals to x, and 90 degrees minus alpha equals to 90 degrees minus alpha. So the second equation states that x equals to 90 degrees minus alpha. But we have already found out that beta in the first equation, that beta also equals to 90 degrees minus alpha. So I write it down. According to equation number 1, angle beta equals to 90 degrees minus alpha. Okay? According to the first equation, beta also equals to 90 degrees minus alpha. So we can combine these two equations together. X equals to 90 degrees minus alpha. According to the second equation, x equals to 90 degrees minus alpha. Okay? According to the second equation, x equals to 90 degrees minus alpha. According to the first equation, 90 degrees minus alpha equals to beta. So we can add here that 90 degrees minus alpha equals to beta. Okay? Again, according to the first equation, 90 degrees minus alpha equals to beta. So I write it here that 90 degrees minus alpha equals to beta according to the first equation, and according to the second equation, x equals to 90 degrees minus alpha. So from this equality, we can deduce that x equals to beta. Okay? So I write it down. Okay, so we got the equality that x equals to beta. Okay, so we know that x equals to beta, so instead of x we can write here beta. I will delete x, and instead of x I will write beta because x equals to beta. Now I will present rule number 3. Rule number 3 states that if two peripheral angles equal to each other, then they rest on equal chords. On equal chords, or equal arcs. So I will read again rule number 3. Rule number 3 states that if two peripheral angles are equal to each other, then they rest on equal chords or equal arcs. So I will give you an example of rule number 3 in order to clarify it. If we have two peripheral angles that are equal to each other, so this is peripheral angle alpha in the blue color, that rests on chord BC, and we have peripheral angle beta, peripheral angle alpha in the red color, that rests on chord EF. Okay, so we have two equal peripheral angles. Both of those peripheral angles equal to alpha. So according to rule number 3, as you can see, angle alpha in the blue color rests on chord BC. So I write it down. Alpha blue color rests on chord BC, and alpha red color this angle alpha in the red color rests on chord EF. Okay, so the blue alpha rests on chord BC, and the red alpha rests on chord EF. So according to rule number 3, the chords of equal peripheral angles also equal to each other. That is to say, chord BC also equals to chord EF because of the fact that those two angles are equal to each other. Therefore also their chords are equal to each other. That is to say, chord BC equals to chord EF. Okay? So, therefore, according to rule number 3, their chords are also equal to each other. That is to say, the chord of the blue color, angle alpha in the blue color rests on chord BC, and angle alpha in the red color rests on chord EF. So according to rule number 3, their chords also are equal to each other. That is to say, BC equals to EF. Okay? So, equal peripheral angles rests on equal chords. This angle equals to this angle, so this chord also equals to this chord. Okay, because equal peripheral angles rest on equal chords. Angle alpha in the blue color rests on BC, and angle alpha in the red color rests on chord EF. Because of the fact that they are equal to each other, the chords that they are rest on also equal to each other. That is to say, chord BC equals to chord EF. Okay? So, we actually can implement rule number 3 in our circle. Peripheral angle BAC equals to beta, and it rests on chord BC. And peripheral angle MAD equals to beta, and angle MAD rests on chord MD. Therefore, according to rule number 3, because of the fact that those two angles are equal to each other, both of them equals to beta. They also rest on equal chords. So, because of the fact that those two angles are equal to each other, that those two peripheral angles, I'll shorten it to angles, but I mean peripheral angles, because of the fact that those two peripheral angles are equal to each other, according to rule number 3, they rest on equal chords. That is to say, so angle BAC that equals to beta rests on chord BC, and angle MAD that also equals to beta rests on chord MD. So according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. So equal peripheral angles, this angle is beta, this angle is also beta, rests on equal chords. That is to say, BC equals to MD. Okay? So we know that according to rule number 3, BC equals to MD. Okay, according to rule number 3, chord BC equals to chord MD, but we know that BC equals to 5 units. Okay, BC equals to 5 units, according to what is given us in the question. BC equals to 5 units. So we can deduce from this equality that MD also equals to 5 units. Okay? It is given us in the question that BC equals to 5 units. And we found out that BC equals to MD. So we can deduce from this equality that MD also equals to 5 units. Okay? So MD equals to 5 units. Okay? So we deduce from this equality that MD equals to 5 units. You can see that the equality MD equals to 5 units. Okay? So we can write here that MD equals to 5 units. Now I will draw again right triangle AMD. So this is right triangle AMD. Side AD of the right triangle of this right triangle equals to 10 units. Side MD of the right triangle equals to 5 units. And AM is actually the hypotenuse of this right triangle. And also AMD equals to the diameter of this circle. So because of this, we will mark it as D, abbreviation for diameter. So the only missing variable is D. We will use the Pythagorean theorem in order to find out the value of D. We also know that the diameter of any circle in the world equals to 2 times the radius. So after we will find the diameter, we will divide the result by 2 in order to find out the radius. Okay, so the Pythagorean theorem states that it is true only to right triangles. You can use it only on right triangles. It applies only to right triangles. So the Pythagorean theorem states that in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. I will read again the Pythagorean theorem. The Pythagorean theorem states that in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so we will implement the Pythagorean theorem in our right triangle ADM. So in this right triangle ADM, the square of the hypotenuse is AM squared. This will be our third equation. AM squared equals to the sum of the squares of the perpendiculars, equals to AD squared plus MD squared. Okay, so in our right triangle AMD, AM squared equals to AD squared plus MD squared. But we know that AM equals to D, AD equals to 10 units, and MD equals to 5 units. Okay, so I write it down. AM equals to D, AD equals to 10 units, and MD equals to 5 units. Okay, AM equals to D, AD equals to 10 units, and MD equals to 5 units. So we can substitute AM by D, we can substitute AD by 10, and we can substitute MD by 5. So we'll do it now. We'll get in the third equation that D squared equals to 10 squared plus 5 squared. Okay, we substituted AM by D, AD by 10, and MD by 5. We got that D squared equals to 10 squared plus 5 squared. 10 squared is 100, 5 squared is 25, so 100 plus 25 equals to 125, so I write it down. So we got that D squared equals to 125. We'll take a root out of equation number 3. We get that D equals to root 125. So we got that, so we took a root out of equation number 3. We got that D equals to root 125. Actually 125 equals to 25 times 5, so I write it down. Okay, instead of 125, I want 25 times 5, because it equals 125 equals to 25 times 5, and we can split the root here to 2 roots according to the rule that the root of AB equals to root A times root B. So according to the rule, the root of a times b equals to root a times root b, you can split the root of 25 times 5 to two roots, to root 25 times root 5. So we split it one root of 25 times 5 to two roots, to root 25 times root 5. We know that the root of 25 is 5, so I write it down. Okay, the root of 25 is 5, so we got that d equals to 5 times root 5. But we know that the diameter of any circle, d is the diameter, and the diameter of any circle equals to 2 times the radius. So we will create the fourth equation that states that d that is the diameter of the circle equals to 2 times the radius. It is true for any circle in the world. The diameter of any circle in the world equals to 2 times the radius. Okay, the diameter of any circle equals to 2 times the radius. That is our fourth equation. But for the third equation, we know that the value of d is 5 times root 5. So we can substitute d by 5 times root 5. Okay. So we substituted d by 5 times root 5. We got that 5 times root 5 equals to 2 times the radius. We divide the equation number 4 by 2. We get that the radius of the circle equals to 5 times root 5 over 2. Okay, we divided equation number 4 by 2, and we got that the radius of this circle equals to 5 times root 5 over 2. Or we can also write that the radius of the circle equals to 5 times 59 units. Okay, we can also write that the radius of the circle equals to 5 times 59 units, or we can write that the radius of the circle equals to 5 times root 5 over 2 units. Okay, so the radius of this circle equals to 5.59 units, or you can also say that the radius of this circle equals to 5 times root 5 over 2 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of this circle. Uh, First of all, we define the term peripheral angle. The definition of a peripheral angle is an angle inside the circle, and the vertex of a peripheral angle is on the circle, and its curves are chords in the circle. So I gave you an example of a peripheral angle alpha. As you can see, the angle alpha is inside the circle, and the vertex of angle alpha is at point A, and point A is on the circle, and the curves of angle alpha are chords in the circle. Curve AC is chord in the circle, and curve AB of angle alpha is also chord in this circle. Okay, so that is the definition of peripheral angle. And in the next step, we draw chord. We do a chord for points A and O. O is the center of the circle, and the touching point of the chord with the circle is defined as M. So chord AM that passes through the center of this circle, that is to say chord AM passes through point O, equals to the diameter of this circle, because of the fact that chord AM passes through the center of the circle, that is to say through point O. So any chord in the circle that passes through the center of the circle is defined as the radius of the circle, and especially chord AM that passes through the center of the circle is defined as the radius as the diameter of this circle. So chord AM is the diameter of this circle. Okay, we also have rule number 1 that states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. Okay, so if we have a peripheral angle ADB, and suppose that chord AB is the diameter of this circle. So actually angle ADB rests on the diameter of this circle. So according to rule number 1, angle ADB equals to 90 degrees because of the fact that angle ADB rests on the diameter of this circle. For that reason, according to rule number 1, it equals to 90 degrees. Okay? We can implement rule number 1 in our circle. We have angle ADB that rests on chord AM, and we have already know that chord AM is the diameter of this circle because of the fact that it passes through the center of the circle. It passes through point O, that is the center of the circle. For that reason, chord AM is the diameter of this circle, and angle ADB rests on AM, that is the diameter of this circle. So according to rule number 1, angle ADB equals to 90 degrees. Okay? Again, chord ADB rests on angle AM, angle ADB rests on chord AM, and chord AM is the diameter of this circle. For that reason, according to rule number 1, angle ADM equals to 90 degrees. Okay? So, actually, in the triangle ADM, ADM is a right triangle because of the fact that angle ADM equals to 90 degrees. And in the triangle ADM, we defined angle AMD as alpha and angle MAD defined as beta. And we know that the sum of the angles in any triangle in the world, especially in the right triangle AMD, equals to 180 degrees. So we can write down that alpha plus beta plus 90 degrees equals to 180 degrees. This is our first equation that states that alpha plus beta plus 90 degrees equals to 180 degrees. Okay? And we got that beta equals to 90 degrees minus alpha. That is our first equation. And then we have rule number 2 that states that if two peripheral angles rest on the same chord, then they are equal to each other. We'll give you an example of rule number 2 in order to clarify it. We have here two peripheral angles, angle alpha and angle beta are peripheral angles, and they both rest on the same chord. Angle alpha rests on chord BC, and also angle beta rests on the same chord BC. So according to rule number 2, they are equal to each other. That is to say, alpha equals to beta. Okay, so we can implement this rule in our circle. We have angle AMD that equals to alpha, and it rests on chord AD. But angle ABD also rests on the same chord AD. For that reason, according to rule number 2, it will also be equal to alpha. Because if you have two peripheral angles that rest on the same chord, then they are equal to each other. That is to say, angle ABD equals to angle alpha because both those two angles rest on the same chord AD. For that reason, they are equal to each other. That is to say, angle ABD equals to alpha, or if angle alpha rests on chord AD, and you have angle ABD that also rests on the same chord AD, then according to rule number 2, they are equal to each other. That is to say, angle ABD also equals to angle alpha. Okay, so angle ABD is alpha, and then we define the angle BAC as angle X, or angle BAC is defined as angle X. So we have in the right triangle ABL angle X, angle alpha, and 90 degrees. We know that the sum of the angles in the right triangle ABL equals to 180 degrees. So we can say that alpha plus beta plus 90 degrees equals to 180 degrees. And that is actually our second equation that says that alpha plus x plus 90 degrees equals to 180 degrees. So from equation number 2 we got that x equals to 90 degrees minus alpha. But from equation number 1 we already know that beta also equals to 90 degrees minus alpha. So from equation number 2 we know that x equals to 90 degrees minus alpha, but from equation number 1 we know that 90 degrees minus alpha equals to beta. So we can write here that 90 degrees minus alpha equals to beta according to equation number 1. And according to equation number 2, x equals to 90 degrees minus alpha. So we have here equality that states that x equals to beta. So we can substitute x here by beta. We substituted here x by beta because x equals to beta. Okay, and we have rule number 3 that states that if two peripheral angles are equal to each other, then they rest on equal chords or equal arcs. So I will give you an example of rule number 3. If we have two peripheral angles that they both equal to each other, the blue peripheral angle equals to alpha and the red peripheral angle also equals to alpha. So if two peripheral angles are equal to each other, then they rest on equal chords. The blue alpha rests on chord BC, while the red alpha rests on chord EF. And according to rule number 3, because of the fact that both those angles are equal to each other, they also rest on equal chords. That is to say, BC equals to EF. Okay, because of the fact that those two angles are equal to each other, they also have equal chords. That is to say, BC equals to EF. Okay, so we can implement rule number 3 in our circle because we have angle BAC that equals to beta and rests on chord BC, and we have also angle MAD that also equals to beta and rests on chord MD. So because of the fact that those two peripheral angles are equal to each other, they also rest on equal chords. That is to say, BC equals to MD. Because of the fact that angle BAC equals to beta and it rests on chord BC, and angle MAD also equals to beta and it rests on chord MD. Therefore, because of the fact that they are equal to each other, they also rest on equal chords. That is to say, BC equals to MD. Okay? So, BC equals to MD according to rule number 3, but we know from the question that BC equals to 5 units. BC equals to MD according to rule number 3, and it is given us in the question that BC equals to 5 units. So we have the equality that MD equals to 5 units. Okay, MD equals to 5 units. So we have the right triangle AMD, that side AMD equals to 5 units, side AD equals to 10 units, and AM is the diameter of this circle. Okay, so I drew the right triangle AMD again. AD equals to 10 units, MD equals to 5 units, and MD is the diameter of this circle. So we can implement the Pythagorean theorem in this right triangle. The Pythagorean theorem states that in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so in our right triangle, it is AM square equals to AD square plus MD square. Okay, but we know, okay, according to the Pythagorean theorem, AM square, the square of the hypotenuse, equals to the sum of the squares of the perpendiculars. AM square equals to AD square plus MD square. But we know that AM equals to D, AD equals to 10, and MD equals to 5. Okay, so we can put the data in equation number 3. We got that D square equals to 10 square plus 5 square, and at the end we found that the D equals to 5 times root 5, but we know that the diameter of any circle, D is the diameter, and the diameter of any circle equals to 2 times the radius. So this is equation number 3 that states that the diameter of any circle equals to 2 times the radius. And we have already know that D equals to 5 times root 5, so we can substitute D by 5 times root 5. We substituted D by 5 times root 5. We got that 5 times root 5 equals to 2 times the radius. We divided the equation number 4 by 2. We got that the radius of the circle equals to 5 times root 5 over 2 units, or the radius of the circle equals to 5 times 59 units. So the radius of this circle equals to 5.59 units, so the radius of this circle equals to 5 times root 5 over 2 units. Okay, thank you very much.